Welcome to part 3 of Life Cycle of a Star. This is a red giant phase. So we've just concluded the main sequence phase where the star was fusing hydrogen into helium. And after we reach a certain percentage of hydrogen uh, having fused into helium, then the hydrogens can't get to each other, so to speak, and so we begin it stops fusing. And as it stops fusing, remember we had that balance between gravity pulling a star in, okay, and fusion pushing it out. Well, if fusion is no longer pushing it out, gravity wins, and the star will begin to compact. Really, first the core will begin to compact, and as that core compacts, well, if it's compacting, it's going to heat up. And as it heats up and reaches about 18 million degrees Celsius, well, then we get to the point where a new kind of fusion could begin. And we can begin fusing helium into carbon. Now, as that happens, the gravity winning only lasts for a very short time because this new fusion creates new explosions outward. And as you can see, the star goes from being normal main sequence type size to when this new fusion begins at these new high temperatures, it pushes out farther. That fusion happens and pushes the star outwards. So as the outer layers of this star begin to expand, well, then we get, as the outer layers begin to expand, the outer layers, there's no fusion going on in the outer layers, they begin to cool down. So they might go from 6,000 Kelvin on the surface to 2,000 or 3,000 Kelvin on the surface, which will make the surface go from whatever color it was to red, because the surface is cooled down, even though the core may be significantly hotter. As you can see in this picture, we take a look at the size of some of the red giants. So here's our sun, like I mentioned, currently at 5,800 kelvins. And the smallest red giant will be, just a little bit bigger than the sun, whereas the largest one you can see is massively larger than the sun. The sun will expand to be approximately the size of the orbit of Venus. So if you remember doing some of the planetary scaling that we did, um, uh, picture the sun, which was about this big, going to the size of the orbit of Venus, which was significantly larger in the scale that we used in class. Um, Once this fusion ends, which won't be nearly as long as the hydrogen fusion lasted because it's at a much higher temperature, and so it's fusing much faster. So maybe, short time compared to the 10 billion years the sun's going to be around. It'll go through this much faster, and once fusion ends altogether, then we head off to the death of a star. The next video will tell you about 3 different options for the death of the star based on the amount of mass that the star began with.